Hello, and welcome to my Algebra 1 review series. This video covers Chapter 10, Section 4, titled Solving Quadratic Equations. By the end of this video, you will have reviewed recent lessons describing the methods of solving quadratic equations. You will review solving quadratic equations by graphing and solving quadratic equations by using square roots. Finally, you will have reviewed the solving of a real-world problem requiring the solution of a quadratic equation. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find this video to be helpful. Thank you. Okay, before we get started, I have a couple of definitions to go over here. A quadratic equation. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a is not equal to 0. This form is called the standard form of a quadratic equation. And to look at it differently, the standard form of a quadratic equation. The standard form of a quadratic equation is the equation that can be written in the form ax squared plus bx plus c equals 0. Objective 1, solving quadratic equations by graphing. The equation x squared plus 3x minus 4 equals 0 is called a quadratic equation. It is related, and its related quadratic function is y equals x squared plus 3x minus 4. The solutions of the quadratic equation and the x-intercepts of its related quadratic function are the same. So no matter how you graph this, you're going to see if you're graphing y equals equal to x squared plus 3x minus 4, the x-intercept you'll find will be the same no matter whether it's use the quadratic equation or the x-intercept is found by the quadratic function. Continuing on with objective 1. Definition: standard form of a quadratic equation. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a is not equal to 0. This form is called the standard form of a quadratic equation. So a quadratic equation can have 2, 1, or no real number solutions. In a future course, you'll learn about solutions of quadratic equations that are not real numbers. In this review, solutions refer to real number solutions. You can solve some quadratic equations by graphing their related functions. Okay, example 1, solving by graphing. Solve each equation by solving the related equation. So we have x squared minus 4 equals 0. We have x squared equals 0, and we have x squared plus 4 equals 0. So let's start with the first one. It says to solve it. So x squared minus 4 equals 0. We know, since there is no b term in this quadratic equation, that our line of symmetry falls on 0 of the x-axis. So as you see right here, where there's my pencil right there, it goes right through 0 and goes down to the center. They all do the same thing. They're right on the y right there. It goes right through the center, goes right through the center, down to 0. That's because there's no b term, okay? And because of that, we know that everything is symmetric about that line. And what they want to know is what are the x, we're looking for the solutions. So that's the x-intercepts. So in the first equation, we can put in, since we know that 0 gives us minus 4, if we put a 0 in for x squared, we're going to get a minus 4, which is right here. Okay, and now we're on either side. That's how deep this equation goes, minus 4 on y. And that's our vertex, 0, comma, minus 4. So now we can go, let's set x equal to 1. If we set x equal to 1, we get 1 squared, which is 1, minus 4 is minus 3. So here we are right here at minus 3. And we can go on the other side of the line because they're symmetrical and get that one. Now we go to 2. If we go up x equal to 2, we're going to find that 2 squared is 4, minus 4 is 0. So there is a solution right there. And we know that we're 2 to the right from the line of symmetry. So 2 to the left will give us the other one, which is negative 2. So that's 2 solutions, plus and minus 2. We have, for this one, the x is right at 0 on y, and the graph is right at 0 on x and 0 on y. It's at the origin. So there's only one solution. X, it can only be 0. Ever, no matter what. It's symmetric about the y-axis at x equals 0. And everything you do from now on, x, it'll just be squared. If you have a 1, it'll be, y will be 1 squared. If you have a 2, it's going to be, 2 squared, which is going to be 4. And it's just going to keep going up on each side. Now the third one, x squared plus 4, is still symmetric about 0 on x. Its y-intercept is plus 4, because if we set x equal to 0, y-intercept is plus 4. That's what it is. 1, 2, 3, 4. You see it. It's right here. And there is no way for us to get an x-intercept. So there are no solutions to this. None at all. The graph opens up. All the graphs open up. So there's no solution. Okay, example 1, check your understanding. Solve each equation by graphing by using the related function. So why don't you go ahead and give it a shot. And when you get back, we'll try them together. Okay, now that you've had time, first of all, what is the related function that we're talking about here? I think what they keep talking about here is y equals x squared minus 1. And over here for b, it's going to be y equals 2x squared plus 4. So if we're going to solve this, there's no b term in either of these. So again, that means that our axis of symmetry is right along, no matter where it ends up being, the y-intercept at this point, it's along this line at the 0 on the x-axis. And we can tell that if we set x, the graphs, I'll say this, both graphs open up because there's a positive a term in both graphs. And if we set the x term to 0, we're going to get a negative 1 for y. So our y-intercept is right here on the first one, negative 1. And if we set the x term to 0 on the second equation, it's going to be plus 4. It's going to be right up here. Since it opens up, I can tell you there are no solutions for the second problem, for b, because you cannot. And why is that? Because you're going to take and you're going to move. If you do, you're going to move. If you use this equation, the standard equation, you're going to move 4 to the other side. It's going to be a negative 4, and you can't take the square root of a negative anything. So this is going to be no solutions, although it'll still run up. Let's go back to the first one. We got a negative 1. Now let's put in a value 1. 1 squared is 1, minus 1 is 0. So when we do 1, we get y is 0. And since the line of symmetry, we're going to have right here. If we put in a 2, 2 squared is 4, minus 1 is 3, so 3. And we're going to go 2 on this side. Oh, 2 right there. So there's our graph right here. Well, not too straight, but there's 2 solutions, negative 1 and 1. So it's negative 1 and 1 are the solutions. This one are no solutions. Okay. If you did try to graph it, if you wanted to, from that point, you could put a value 1 in and get 2 plus 4 is 6. So if you do over 1, you'd be at 6. And you'd be at negative 1. So the curve, you can tell the curve is already going to go like this, up in there. Okay, example 1, check your understanding. This is the second slide. Solve each equation, well, there's only one in this slide, by graphing the related function. So go ahead and do it. When you get back, we'll try this one together. Okay, now that you're back, let's see what it is. So the related function is going to be y is equal to what? Negative 16. Now it equals 16. It says we have to move the negative 16 to the other side. And when we do that, it's going to be y equals negative 16 plus 16, which is 0. So it's going to be x squared plus 0. So y equals x squared. So if that's the case, we know that there's no b term, so we know that the axis is on the line of symmetry. If I can draw it here, the line of symmetry is going to be right down here through the x equals 0, and that it's going to be a graph opening upward because the a value is positive, and it's just a standard quadratic. So if x is 0, y has to be 0. So we're going to put here is I'm going to change colors just to have a little fun here. So 0 that's the origin, if you will, right here, and that's also the vertex. So the vertex is at 0, 0. Okay, and we can just plunk in values now. How about x equals 1? If x equals 1, it's 1 squared is 1 plus 0 is 1. So we go 1, we're at 1. And we go over here, -1, we're at 1. Because it's squared. When you do 2, when you put 2 here, it's 4. Because 2 is squared. And you go over 2 this way. And if you want to get up further, 3 is going to be 9, and it's way up here somewhere. 3, 1, 2, 3, 9 will be up here. Anyways, if you come down and try to graph that, it's going to go something like that, right? It's probably one of the better graphs I think I've drawn. And that's it. That's our graph using the related function. Okay, it says you can solve equations of the form x squared equals a by finding the square root of each side. Since 6 squared is equal to 36 and minus 6 squared is equal to 36, both are true statements. 6 and -6 are both solutions to the equation x squared equals 36. We write the solutions to x squared equals 36 as either plus or minus the square root of 36 or plus or minus 6. Oh, example 2, using square roots to solve this. So to solve the problem, 2x squared minus 98 equals 0. So the way we're going to do it is we're going to follow as we've written it down here, we're going to write the equation. We have 2x squared minus 98. We're going to add 98 to both sides. Okay, so we're going to then end up getting with 2x squared is equal to 98 because we put the positive 98 over here, and these two 98s canceled right here, cancel each other out right there. Okay, so now we have 2x squared is equal to 98. Now we can divide both sides by 2. Okay, and we end up with x squared is equal to 49. Okay, take the square root of both sides. Take the square root of x squared, square root of x squared, and the square root of 49. Right? We get x equals plus or minus the square root of 49. We said that's a way of writing the solution. Or the previous slide said you can also have it plus or minus 7. So that's the answer. It's plus or minus the square root of 49, or x equals plus or minus 7. That's the solution using square roots. Okay, example 2, checking your understanding. You can go off and do these yourselves. And it's exactly the same thing we did on the previous slide. So take your time, and when you come back, we'll start it up. Okay, I'm assuming you've done it. You've paused the video, and you're back, and we're ready to go. So let's go to problem A. So what did we do in the last one? We took and we wrote the equation, t squared minus 25. I always like to write the equation equals 0. Now we're going to solve for t. So t squared minus 25 plus 25 is equal to 0 plus 25. These two 25s cancel each other. We end up with t squared is equal to 25. Take the square root of both sides. Square root of t squared, square root of 25. And we end up with t is equal to plus or minus 5. Or you could have said plus or minus the square root of 25. Okay, let's do B. 3n squared, I'm going to write it down, 3n squared plus 12 equals 12. So let's go ahead and solve this. So we're going to solve for n in this case. So we're going to move the positive 12 to the other side. Okay, so we're going to end up with 3n squared plus 12 minus 12 is equal to 12 minus 12. And when we go to the next step, we have 3n squared is equal to, the 12's canceled here, the 12's canceled here, is equal to 0. So just so happens that the answer is 0 because there's nothing you can put in for n. We're going to get answer 0, right? So 0 divided by 3 is 0, and the square root of n and the square root of 0 is 0. So the solution, the answer is n equals 0. And now let's do the last one. We're going to do the same thing. So we have 2g squared plus 32 equals 0. 2g squared plus 32 minus 32 is equal to minus 32. These 32's cancel over here. So we get 2g squared is equal to minus 32. We can divide both sides by 2 and get g squared is equal to minus 16. And now we're trying to take the square root of g squared and of minus 16. And what do we get? We'll get g is equal to what? We can't do it. We're stuck with the square root of negative 16. We can't take the square root of a negative number. So there is no solution. No solution. Because we ended up with a negative under the radical right sign. Okay? Okay, example 3, the real world problem. They want us to find, what is it? The radius is a city park. A city is planning a circular duck pond for a new park. The depth of the pond will be 4 feet. That's the H value, right? 4 feet. Because of water resources, the maximum volume will be 20,000 cubic feet. Find the radius of the pond. Use the equation V equals pi r squared h, where V is the volume, r is the radius, and h is the depth of the pond. So I'm going to go ahead and write the equation. I'm going to write it one time. V is equal to pi r squared h. Now we'll fill in we'll substitute in, so we have 20,000. 20,000 is equal to pi times r squared times 4. Now we've got to solve for r squared. So we're going to get the r by itself. So in order to do that, we're going to divide both sides by pi and 4. So we're going to end up over here with pi divided by 4, or 4 pi, and 20,000 divided by 4 pi. And we have, on this side, we have the same thing divided by pi times 4. So now the pi and the 4 disappear, these disappear, and we end up with 20,000 equals, 20,000 divided by pi times 4 is equal to r squared. Well, we can take the 4 out of the 20,000 and get 5,000. So we're going to have 5,000 divided by pi is equal to r squared. Now, what is 5,000 divided by pi? 5,000 divided by pi is equal to 1591.549. That's close enough, I guess. And we're going to take the square root of both of these. So we're going to say r squared, square root thereof, is equal to the square root of 1591549, and that equals r equals, or not r squared, excuse me, I'm getting carried away with my writing here, r is equal to plus or minus the square root of this number here, which ends up being 39.894, and it goes on and on and on. 222.639. Okay, so what we're going to say here is that the depth of this pond, or the radius of this pond, is 39.9. What kind of answer do we want? I'm going to say that we probably want an answer that is, well, just the full answer, I guess, is what they're asking for in the book. So that's it. So the radius, I'm going to make it a little shorter. I'm going to say the radius is equal to 94222 feet. Okay, that's what the radius of this pond will be. Okay, check your understanding. This is basically the same problem. You can go off and do it on your own, and when you come back, we'll work it together. The equation is there, so you don't have to even look at the pond. You know the steps. I'll wait. Okay, now that you're back, let's give it a shot. A city is planning a circular fountain. The depth of the fountain will be 3 feet. The maximum volume will be 1,800 cubic feet. Find the radius of the fountain. Use the equation V equals pi r squared h. Okay, so I'm going to write it down. V is equal to pi r squared h. And what do we know? We know pi. We know the volume, 1,800 cubic feet is equal to pi times, we don't know r, and we know h is 3 feet. They tell us that, 3 feet right here, 3 feet. Okay, so now we're going to solve for r by itself, right? So we're going to divide both sides by 3 and both sides by pi. So we're going to get 3 pi, we're going to divide by 3 pi on this side, and 3 pi on this side. The pi's will cancel, the 3's cancel, and the 3 over here cancels into this and gives us 600. So now we have 600 divided by pi is equal to r squared. And if I take it this way, 600 divided by pi comes out to 190.985. We want to go further. 931. That's far enough. Okay. Now we have r squared is equal to 190.98. So now we're going to take the square root of both sides. The square root of r squared is equal to the square root of 190.985,931. Okay. And now we're going to find out that the square root of r squared is r, and that's equal to plus or minus. Square root of 190 is going to be 13.819. And that's going to be feet, by the way. Okay? So I guess we can average this. We can say it's 13.819 feet, or it's plus or minus, but we're going to say that r is approximately equal to 14 feet. Okay? That's the answer to that. And also notice that we never use the negative value because this is the real world. We can't use the negative radius on a pond or on a fish tank or a duck pond or a fountain. You can't use negative numbers. You only can use the positive. The negative comes along for the ride, I guess, but we don't use it. Okay?